Hey there, Mr. Weaver here with Lesson 2 of Topic 1, the rules for adding and multiplying rational and irrational numbers. If you have not already done the exploration for Lesson 2, please do that first before watching this video. After completing this lesson, you need to be able to explain why the sum or product of two numbers is rational or irrational. And you also need to be able to develop and generalize rules for those operations of rational and irrational numbers. After this lesson, you'll know you're successful if you can explain if the sum or product of two numbers is rational or irrational, and if you can create rules for sums or products of numbers. In this lesson, we'll have a couple different combinations of rational and irrational numbers. Let's start with the sums of rational and rational, r and r. So let's choose an r, say negative 7/2, and add it to another r, 0.4, 4/10. If we were to add them together, we would get negative 3.1 or negative 3 1/10. Okay, I converted my fraction to a decimal and added them, or I could convert my decimal to a fraction and add them. Either way, I get negative 3.1 or negative 3 1/10. Both of those answers are rational numbers. So if I chose a rational number to begin with and add it to another rational number, I still get a rational number. A rational plus a rational is rational. R plus R equals R. Next, let's look at the products. So if we choose a rational number product, 3/4, it's R, and we multiply that by another rational number, 0.32, 32, 32, etc. So 32 repeating is R. We end up with 24 over 99 as a fraction, or 0.242424, and so on. Again, both of those numbers are rational. So a rational number times a rational number is also a rational number. So in general, if you only have r's, only rational numbers, if you add them or multiply them, you're going to get another r, another rational number. Now let's look at what happens if we pair an r with an I, a rational with an irrational. Okay, again, let's start with the sums. So I chose negative 3/8 as my rational number. I'm going to add that to an irrational number, such as the square root of 10. In order to do this, I'm going to convert both of them to decimals. So negative 3/8 is negative 0.375. Add that to the square root of 10, which is 3.16227766, ... and so on. Adding that together, I get 2.787277, and then the rest of it's the same as the square root of 10 was. Take a look at what happened. It goes on and on and on, and it doesn't end. That's irrational. If I take a rational number in R plus an irrational number in I, I'm going to end up with an I. Okay? The irrational number is ending, the fact that it goes on forever and ever, just kind of overwhelms the rational number, takes it over. It's going to create another I. Okay? So now let's look at the products. Let's say I have negative 1/2, negative 0.5. I'm going to multiply that by negative pi, because pi is I. Again, I'm going to see what it comes out to be. So if I were to multiply these, negative 0.5 times negative pi, 3.14159.265, etc., I end up with 1.5707, and so on. You can see what it looks like. What did that come out to be? Well, again, that's irrational. So a rational number times an irrational number is also an irrational number. R times I is I. So adding an irrational number made an irrational number. Multiplying an irrational number makes an irrational number. There is one exception. 0. Because 0 times anything is 0. Okay, which is rational. So our rule, rational times irrational, is going to be irrational. R times I is I, except when it's with 0. Okay, 0 is the only way you can get an R. So if you can remember that one exception, there you go. So in this lesson, we came up with some rules for dealing with rational and irrational numbers. The sum or product, okay, adding or multiplying two R's is going to give you another R. The sum or product of an R and an I is going to be an I. Okay, so if there's an I involved, it's probably I. The only exception is with 0. That will give you an R. After watching this video and completing this lesson, do you know how to explain if the sum or product is rational or irrational? And can you create a rule for the sum or product of two numbers? And that's it for lesson 2.